All right, so write the product of powers as a single power, then evaluate the power. As we just talked about in our warm-up, this means there is a total of 1, 2, 3, 4, 5 now. 2 to the 5th. And then what we talked about, this is called the product law. So what that would be is it's 2 to the 3 plus 2. We add the exponents. That's what we're looking for. Okay, which gives us 2 to the 5th.
It says to evaluate.
Right, it says to evaluate, and then 2 to the 5th is close. 32, one too many. 2 to the 6 is 64. Okay, good. Next one, -3 to the squared, -3 to the 5th. Okay, so I'm going to write this out because it asked me to the first time. We won't do that every time. Times okay, 1, 2, 3, 4, 5, 6, 7. We have 7 now. So I want to ask you before we go any further, is your answer going to be positive or negative? Negative, good. It's an odd exponent. Therefore, we're going to have one left over that messes everything up. If you don't like negatives, I guess. If you like negative, it makes everything great. Okay, what is -3 to the 7th? So -2,187. Okay, that would be your solution there. All right, so we have, well, let's do the show you know, and then we'll go back to the back. Okay, so let's move to the show you know here. So it says evaluate each expression in 2 different ways. Okay, so repeated multiplication, so they just want you to write the 4s in here. So then you see you have a total of 8. So 4 to the 8. I don't like how that's written. Don't like that either, but oh well. Okay, so 4 to the 8th is equivalent to what? So we got 65,536 for evaluating. Perfect. Okay. Then this way is just using your exponent laws now. So we're getting you away from having to do this tedious work here because like we just know it's 3 plus 5, which is a lot easier. And we can draw, it's the same number, obviously. We don't have to write out that big number again. Okay, and then for part B, we're just going to do the one way. We don't need to do the other way, but it's one thing I want to focus on. It's -5 to the 2 plus 3, -5 to the 5th. So J, is that going to be positive or negative? Negative. Odd exponent, negative number. Somebody got that one for me? What's -5 to the 5th? So if we evaluate it, that's the evaluation. Okay, perfect. So let's scroll to the last page, and we're going to write in that law now. Okay, we're going to write it in general terms. Anybody know what that means? Yes and no. Okay, the only thing about easiest is like depends what you mean by easiest. General terms means is that we can't say the law, like for example, if I was writing a law, I can't say 3 squared plus 3 cubed is 3 to the 5th, because then people are going to think, oh, so it's always a 3. Right? Because you're giving a number for the base. So when you say general, what you want to do is use variables. Because we're saying this is the pattern. We don't know the numbers because the numbers are going to change. Yeah. So I actually prefer, I don't know why with exponents, I prefer a to the m times a to the n. Got that? Equals a to the m plus n. That's the exponent law for product. Question on that? Perfect. All right, so then let's go back to the show you can know, or excuse me, back to that example 2 where we're going to switch to division now. All right, so Okay, so we got write each exponent as a single power, then evaluate the power. So I'm still going to write this out just for practice for the first 2 times, okay? After that I won't. So I have 6 2's over 2 of them. Cancel, cancel. I have 4 left, which is 16. Okay, but in terms of writing with the exponent laws, we understand from our warm-up now, and hopefully from this you can see it's essentially 6 minus 2. So it's 2 to the 6 minus 2 is 2 to the 4th. Okay, we just see we have the same thing there. Okay, I lied. I'm only going to do it for one of them because I don't really feel like writing out 5 or 9 negative 5s. Okay, so negative 5 to the 9th divided by negative 5 to the 6 is going to be negative 5 to the 9 minus 6 equals negative 5 cubed. Okay, Kale, is that going to be negative 5 cubed? Is that going to be negative or positive? Attaboy. Okay, negative 5 cubed is going to be negative. Perfect. And it'll be, I know this one, I think, negative 125. Okay. Questions? Is he bored yet? Just too bored? Boring? Yeah. You want it to be harder? No? All right, let's show you know here. Okay, that's, I think yours, is yours look like that? No. Yours has a division sign, right? Yeah, it's a little glitch on mine. I think I remember that from last year. Okay, so this division here, 2 to the 5th divided by 2 cubed, so 2. Okay, again, we see that cancel, cancel, cancel. We're left with that, which is 2 squared, which is 4. So essentially, it's 2 to the 5th minus 2 cubed, or minus 3 there. 2 squared, which is 4. Okay, and we'll get this last one here on the bottom. We'll just do the quotient rule here. So this will be your quotient rule of powers. Negative 3 to the 7 minus 4. Negative 3 cubed. So negative 3 cubed, that's going to be negative 27. All right. All right, so quickly, let's go do the rule real quick, and then we have one more. 1.5. Dividing powers of the same base. Okay, so for writing this in general terms, I'm going to write a to the m over a to the n equals a to the m minus n. Does order matter? Yes, definitely for division and subtraction, order matters. Okay, you guys understand that, right? 3 plus 2 and 2 plus 3 are both 5, no problems. 3 times 2 and 2 times 3 are both 6, no problem. 3 divided by 2 and 2 divided by 3, we have problems. They're different. 3 minus 2 and 2 minus 3, they're different. So division and subtraction aren't interchangeable. Okay, so order does matter. Okay, good. Here we go. Now we're going to the third one, where people often confuse with the first one. It's this right here, right? Okay. So write 2 cubed squared as a single power, then evaluate. So what I want to do first, I'm going to write this out. So if I have 2 cubed squared, I really have what? I have 2 cubes. And we don't need to write this out because we know that would be addition, correct? 2 cubed times 2 cubed is 2 to the 6th. Okay, if you're asking why did I do this, well, it says I have 2 of these, so I wrote 2 of them.
But isn't it because they're in the brackets, you have to do 2/3 first, and then once every other, you have to square that?
Okay, good, except for this is a law that we're introducing with exponents where we're going to tell you that you can just multiply those. Okay, right. Does that make sense? So what Luke is saying is, correct me if I'm wrong, Luke, but you're asking, do I make this an 8 and then square it?
That's what I did first, and then it's the same answer.
Right. Okay, and so what we're getting to is that, you see, guys, we have 2 of these, right? You see that? We have 2 3s because we times it by that number. So this rule is called power to power. You multiply the exponents. So it's going to be 2 to the 6th. Okay, and then 2 to the 6th is 64. Okay? So this is power to power. The biggest thing people get confused on is confusing this one with rule number 1 we learned today. Notice the difference. Exponent to exponent, right on top of each other. Power to power. You multiply them. Okay, now going back to what Luke said, because this is actually really important now because we have a 2 and a negative 3. So we can do two things here because it's a product. We can hit the 4 on both of them, or we can simplify first. Both will be correct. Okay, so let's do this here. I'll show you. So it wants a product of 2 powers, so I'll do it their way first, which would be 2 to the 4th times 3 to the negative 4th. Not negative 4th. What am I talking about? Negative 3 to the 4th, sorry. Like that. Okay? And I'll show you. 2 to the 4th is 16. 3 to the 4th is 81, positive. Let's see here. 8, 10, 480. 1,286? 96. Okay. 1,296 is that answer there. Okay. If we go ahead and multiply them now, that's 2 times a negative 3, right? What's that? Negative 6. And then we take the negative 6 to the 4th, which is also 1296. So in this case, you can do either or. It's showing, and the reason is because multiplication is interchangeable. Is everybody good with that? This one's an important one here because even my Math9s forget this stuff. Okay? When you have a fraction with an exponent, the exponent hits the top and the bottom. So the 3 hits the 3 and the 4. Okay? Well, 3 cubed, right? Yeah, so we're going to go 3 cubed over 4 cubed. Now these they're not same basis, so we're not doing our quotient rule or anything. We're evaluating from here. So it's going to be 3 cubes 27, 4 cubes 64. And I think 2764 is the best it can be. Does that make sense? So again, when you have a bracketed fraction with an exponent, the exponent hits the top and the bottom. Okay? All right, so let's go and write that rule here. That's all right. All right, so raising a power to an exponent, so this is where it's going to be a to the m to the n. That is a to the mn. Letters next to each other means multiplication, so it means you multiply m times n. Okay, good. All right, last couple pieces here. So this show you know. So write 3 squared cubed as a single power in 2 different ways, then evaluate. So repeated multiplication would be 3 squared, which is 3 times 3 times 3. So then you see we have a total of 6. Okay. And then doing our exponent laws, it'd just be 3 to the 2 times 3, which would be 3 to the 6th. Okay, what is 3 to the 6th? 729? Okay, so 729. Good. All right, then we're doing this one in the 2 ways here. So they're doing repeated multiplication. So 5 times 4 times 5 times 4, which is 20 times 20, which is 400. And this way they're doing 5 squared, 4 squared, 25 times 16, which is 400. So both ways work there. All right, moving up. Okay, so then we have 2 to the 5th, 2/5 to the 5th as a quotient of 2 powers and evaluate. So we're going to write this one out. We got 5 of them. Okay, so we have 5 of them. So we have 2 to the 5th, whoops, over 5 to the 5th. Exponent laws just tells us to make it to the 5th for top and bottom. It's kind of like distribution in a way. Okay, which 2 to the 5th is 32. And 5 to the 5th, is that the 3, 1, 2, 5? Yeah. Okay. Okay, there we go. And we have one more rule to learn. Okay. So, evaluate 3 to the 0. Okay, evaluate 3 to the 0, yeah. 1, right? I think we briefly talked about this. Okay, it's 1. Just a 1, that's all it is. We're going to talk about why using this chart. 3 to the 4th is 81, 3 cubed is 27, 3 squared is 9, 3 to the 3rd is 3, and then we have a 1. The reason being is, showing right here, this is the pattern. 81 divided by 3 gives us what? 27. Watch this pattern. 27 divided by 3 gives us 9. So you see 81 divided by 3 gives us 27. 27 divided by 3 gives us 9. 9 divided by 3 gives us 3. And then 3 divided by 3 gives us 1. Okay? Here's the proof, okay? Or here, we'll do the proof on B. So it's asking for the proof. I will prove to you why negative 2 to the 0 equals 1. Prove it. Okay, this is what we can do. We can prove it using the quotient of powers. I'm going to do negative 2 over cubed, and I'm going to do negative 2 cubed. So let's just take a second, hold on. Anything over itself is 1. We all agree on that? I mean, in math, we could be silly. We can do a smiley face over a smiley face, and that's still, that's 1. Anything over itself, doesn't matter. Just 1. Okay, because in this case, Luke, they're both negatives. So I see what Luke's saying. These are actually, the values are negative 8 over negative 8, but it's negative over negative, so we're still there. Oh, this? Yeah, that's still positive. Unless you're going to have a bad day, make it a negative. Okay, so what we have now is, though, what we're proving is because the quotient rule says subtract the powers. So if I subtract the powers, I get 3 minus 3, which is 0. Well, we know it's 1, so then negative 2 to the 0 is 1. Okay? It's not 0. Just make sure you never put 0, okay? It's not 0. So evaluate each expression. This one, they're just messing with the negatives on you now. That's knowing our negative rules. So the whole thing's b to the 0 power, so it's going to be a positive 1 here. The negative's outside, so it's going to be a negative 1. Does a 0 affect the negative here?
Yes.
No. The 0 is only on the 5. That's the difference, right? These two. These two are related. This guy, the negative's involved. This guy, the negative's not involved. Okay, and this one's simply just a 1, because there is no negative. Okay, that is where most of you are going to make your mistakes on your assessment, so make sure you get your negatives down. All right, let's finish that last rule down there. Okay, so a to the 0 power is 1. Anything to the 0 power is 1. All right.